Our introduction of the unit circle. There are notes in OneNote if you'd like to follow along there. Otherwise, you can follow along right here. So we're going to be learning about the sine and cosine in quadrant 1 and the axes. And to start with, we're going to recall what we learned the past 2 weeks. And we're going to use SOHCAHTOA in order to find the different degree measures. Last semester, we learned about special right triangles, which were 45, 45, 90 triangles and 30, 60, 90 triangles. We're going to be using those charts in order to figure out our missing side lengths. So to start with, we're going to use this triangle with a hypotenuse of 6 in order to answer the following questions, which is finding the value of x and y first. So I'm going to set up my 45, 45, 90 chart. So we have x, x, x square root 2. 6 is along the hypotenuse, so I'm going to set x root 2 equal to 6. And we're going to have to solve for x. So I'm going to divide each side by root 2. It cancels on the left, but it does not on the right, so we're left with x equals 6 over root 2. I have to rationalize the denominator, so I'm going to multiply the numerator and denominator by root 2. So we have 6 square root 2 over root 2 times root 2 is 2. And then we have to simplify. 6 over 2 is 3. So we're left with 3 root 2 is equal to x. So across from both 45-degree angles is 3 square root 2. In part C, it says to find the cosine of 45 degrees. We know cosine is adjacent over hypotenuse. So therefore, we're going to set 3 square root 2 over my hypotenuse, which is 6. We can go ahead and reduce 3 over 6. So we're left with cosine of 45 degrees is square root 2 over 2. In part D, it says to find the sine of 45 degrees. We learned last week sine is opposite over hypotenuse. So therefore, I'm going to take my opposite side over the hypotenuse side. So we have 3 square root 2 all over my hypotenuse, which is 6. Let's go ahead and reduce 3 over 6, so we're left with square root 2 over 2. So we found the sine of 45 degrees to be square root 2 over 2. So this one was just a triangle. In this next diagram, we still have a right triangle, but now it's inside of a circle. We're going to use the diagram to answer these questions. In part A, it says, what is the radius of the circle? So I know that the radius is anywhere from the center to the outside of the circle. Now there is no number along that line. So center to the outside of the circle, no number along that line. However, from the center to the outside of the circle, there's my radius. So therefore, my radius of the circle is 1. In part B, it says find the value of x. In part C, it says find the value of y. So once again, we're going to set up my 45, 45, 90 chart because we have the hypotenuse of this right triangle is 1. So we have x, x, x square root 2. So I'm going to set x root 2 equal to 1. Now I have to find x. So I'm going to divide each side by root 2. Cancels on the left, it doesn't on the right, so I'm going to rewrite this. So x equals 1 over square root 2. Let's rationalize the denominator. So we have to multiply the numerator and denominator by root 2. So we have 1 root 2, which is root 2 over root 2 times root 2 is 2. We found that x is square root 2 over 2. And we could put that in both columns for 45 degrees. So across from both 45-degree angles in my picture is root 2 over 2. So therefore x is root 2 over 2 and y is also square root 2 over 2. So in order to find the cosine of 45 degrees, I'm going to take the adjacent side over the hypotenuse. So based on this angle, we have the opposite side, the adjacent side, and the hypotenuse. So I'm going to take my adjacent side, which is square root 2 over 2, all over the hypotenuse, which is 1. From there, we can simplify to just square root 2 over 2. So therefore, cosine of 45 degrees is equal to root 2 over 2, just like above, when cosine of 45 degrees was also root 2 over 2. So let's now find the sine of 45 degrees. Well, we know that sine is opposite over hypotenuse. So I'm going to take my opposite side, which is square root 2 over 2, over my hypotenuse, which is 1. Let's go ahead and simplify this. So we're left with square root 2 over 2. So sine of 45 degrees is root 2 over 2, just like above, where the sine of 45 degrees was also square root 2 over 2. That's one of my special right triangles. Here's another one. So my reference angle for this special right triangle is 30. So in order to find x and y, I'm going to set up my 30, 60, 90 chart. So we have x square root 3, and 2x. The hypotenuse is 8. So therefore, I'm going to set 2x equal to 8. So now that the hypotenuse is 8, we have to solve for the other sides, x and y. So I'm going to divide each side by 2 right here so that we get x alone, which is 4. So I'm going to take x equals 4 and plug it into my chart. So we have 4 and then 4 square root 3. Across from 30, we're going to go ahead and write down 4. And then across from 60, we can go ahead and write down 4 square root 3. So therefore x, 4 root 3, y is 4. For part C, we're going to find the cosine of 30 degrees. So based on this 30-degree angle, we have the opposite side, the adjacent side, and the hypotenuse side. Cosine is adjacent over hypotenuse, so therefore I'm going to take 4 square root 3 all over my hypotenuse, which is 8. So we have to reduce this, so we have 4 over 8. So we're left with square root 3 over 2. In the next one, we have sine of 30 degrees. So sine being opposite over hypotenuse, we're going to take our opposite side, which is 4, over my hypotenuse side, which is 8. Let's go ahead and simplify. So we have 1/2. So the cosine of 30 degrees is square root 3 over 2. Sine of 30 degrees is 1/2. Now in this picture, we have another reference angle of 30 degrees. To start with, it says in part A, what is the radius of the circle? So once again, from the center, the outside of my circle, the radius is 1. Next, it says to find the value of x. So I'm going to set up my 30, 60, 90 chart. We have x square root 3, and 2x. The hypotenuse is 1, so I'm going to set 2x equal to 1. Now I have to solve for x, because we need to input it into the other two columns. So we're going to divide each side by 2. So therefore x equals 1/2. So you can go ahead and put 1/2 right here. And then we have 1/2 next to the root 3. I'm going to rearrange 1 over 2 root 3 so that both 1 and root 3 are in the numerator, and 2 times 1 is 2. So I'm going to rewrite this so that we have root 3 over 2 right here. So across from 30 degrees is 1/2. And across from 60 degrees is square root 3 over 2. So now we have our values in order to figure out what the cosine of 30 degrees is. So based on my 30-degree angle, we have the opposite side, the adjacent side, and the hypotenuse. So for cosine of 30 degrees, we have adjacent over hypotenuse. My adjacent side is square root 3 over 2, and the hypotenuse is 1. Simplify this so that it's just itself, root 3 over 2. Next, to find the sine of 30 degrees, we have the opposite over hypotenuse. So I'm going to take my opposite side, which is 1/2, over the hypotenuse side, which is 1. Simplify it. So that's just 1/2. So cosine of 30 degrees was root 3 over 2. just like above, cosine of 30 degrees was also root 3 over 2. And in this one above also, sine of 30 degrees was 1/2, just like this sine of 30 degrees is also 1/2. And this does not happen to be a coincidence, and you'll see that later on. For our last special right triangles, we have 60 degrees as our reference angle. So we're going to use our 30, 60, 90 chart with a hypotenuse of 12 in order to figure out what x and y is. So we have 30, 60, 90, x root 3, and 2x. 12 is the hypotenuse, so we're going to set 2x equal to 12. We have to solve for x in order to fill in the other columns. So I'm going to divide each side by 2, so we have x equals 6. You can put 6 for x and then 6 root 3. So across from 60 happens to be y, so we have 6 root 3 for y. And across from 30 is x, so we have 6 for x. Now let's go ahead and figure out the sine and cosine of 60. So based on 60, here's my opposite side, my adjacent side, and the hypotenuse. Cosine is the adjacent over the hypotenuse, so therefore I'm going to take my adjacent side, which is 6, and put it over the hypotenuse, which is 12. Let's reduce this. We get 1/2. Let's take the sine of 60 degrees, which is opposite over hypotenuse. My opposite side is 6 square root 3 over the hypotenuse, which is 12. Let's simplify. We get square root 3 over 2. So cosine of 60 degrees is 1/2, and the sine of 60 degrees is square root 3 over 2. We are on to our last triangle within a circle, and it starts out by asking what is the radius of the circle, and we know that the radius of the circle, based on the past 2 problems that we've done just like it, is 1. Next it says to find the value of x and find the value of y. Well, this is another 30, 60, 90 special right triangle, so I'm going to go ahead and use what we did earlier. The same work would apply for this circle also. Now across from 60 is square root 3 over 2. That happens to be y, so we're going to write down square root 3 over 2. And across from 30 is x, which is 1/2. If you are taking notes, you'll notice that those are opposite. The x and y are opposite of the 30, 60, 90 from above. So next one, since we have a reference angle of 60 here, we have our opposite, adjacent, and the hypotenuse. Cosine is adjacent over hypotenuse, so I'm going to take my adjacent side, which is 1/2, over the hypotenuse side, which is 1. Simplify, so we have 1/2. So the cosine of 60 degrees is 1/2. And then let's find the sine of 60 degrees. So we have opposite over hypotenuse. So I'm going to take my opposite side, which is square root 3 over 2, over my hypotenuse, which is 1. Simplify, so we have square root 3 over 2. So the cosine of 60 degrees is 1/2, just like above. The cosine of 60 degrees was also 1/2. Just like in this sine of 60 degrees, we have root 3 over 2. And in this one, we have the sine of 60 degrees is also square root 3 over 2. So anytime that we have a reference angle of 45, 30, or 60, you're going to see these numbers 1/2, root 3 over 2, and root 2 over 2 as we learn about this unit circle in the next video.